A'udzubillahiminasyaitonirrajim. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Okay, for today, we as a group are going to present our topic in presentation assessment physics 0235 entitled electric potential. Okay, so let me introduce myself and my team. Firstly, my name is Akidenish bin Yusof from section 418 and number metric 210892. And then Muhammad Raif bin Romli, his number metric is 212037. And brother Muhammad Farihin, his number metric is 211878. And next, brother Hamis Muaz, his number metric 211885. And lastly, brother Muhammad Imran, his number metric is 212052. Okay, without wasting any time, first I will present briefly about electric potential. Here is our notes. So what is electric potential? Electric potential can be defined as dividing the potential energy by the charge given a physical quantity that depends only on the source charge distribution and has a value at every point. So at here we can know that at every point it has certain value. Okay, so let's move on to this figure that has positive charge and negative charge. Okay, at positive charge it has high potential energy and negative charge low potential energy. So it can be concluded it has no influence of gravity. That's the first one. Second one is point A and B have different potential. As I said just now, at every point it has certain value. And the last one, electric potential, V. Its unit is Newton meter over Coulomb. Okay, let's move on to the other one. The potential difference between 2 points separated by a distance D in a uniform electric field E is delta V is equal to negative ED. Delta V is the change of electric potential. Negative E is electric field and D is delta X, also known as distance. If the direction of travel between the points is in the same direction as electric field. Okay. Electric potential energy, U. The unit is U. The symbol is U. The electric potential can be defined as delta V equal to delta U over Q. Delta V is electric potential, delta U is electric potential energy, and Q is charge. Delta V and delta U are scalar quantity, so it has just magnitude, not direction. Okay, to find work. When charge is forced to move, there will be work. So work can be defined as work is to Q times delta V. Q is charge and delta V is electric potential. The electric potential energy associated with a pair of point charges separated by distance R1 towards 2 also can be written as R12 is UE is equal to K is constant, Q1 times Q2 divided by R1 towards 2. We obtain the potential energy of a distribution of point charges by summing terms like the equation over all pairs of equation. Okay, move on to next page. Total potential energy of the system of 3 charges is UE is equal to K is constant, in the bracket U1 plus U2 plus U3. Constant will be factorized and we just add Q1, Q2 over radius. So it has summarized here, electric potential due to several charges, V is equal to K times summation of Q over R, while R is distance between the charge to a particular point. Okay, conductors in electrostatic equilibrium. As in chapter 2 and chapter 3, as we know, conductor is the thing have free electrons, free to move. So electrostatic equilibrium, when there is no net motion of charge within a conductor. Okay, so here I'm going to explain properties of a conductor in electrostatic equilibrium. First one, the electric field is zero everywhere inside the conductor, whether the the conductor is solid or hollow. The second one, if the conductor is isolated and carries a charge, the charge resides on its surface. That the electric field at a point just outside a charged conductor is perpendicular to the surface of the conductor and has a magnitude theta over E naught, where theta is the surface charge density at that point. And the last one, on an irregularly shaped conductor, the surface charge density is greatest at location where the radius of curvature of the surface is smallest. The electric potential due to a continuous charge distribution is V is equal to K integration of dq over R. Every point on surface of a charged conductor is electrostatic equilibrium is at the same electric potential. The potential is constant everywhere inside the conductor and equal to its value at the surface. So that's all from me for brief explanation. And let's move on to our 4 questions to make our understanding better. So let's move on to Brother Muhammad Raif to explain example 1. The mic is yours. Thank you.